Hello and welcome to another video, this time on question 4 from 2019 Mechanics A2, and it's a wonky moments question. So let's have a go. Okay, we've got a ramp AB of length 8 meters, mass 20 kilograms. I'm going to quickly scan down to see if it's uniform. Yep, it's a uniform rod. So straight away, I'm going to put the mass on at 4, round about here. Yeah, it's going to be hard to draw this carefully. I suggest always drawing out a fresh diagram, but I'm a little bit constrained just because I'm on this graphics tablet and it's a bit awkward. So I'm going to go that as theta. That's actually come out as relatively neat for me. 20G. Yeah, so we've got the mass on. On these questions, I also think, is it rough? If it's rough, then I think, well, I want a normal reaction going out here and a friction going out here. Yeah, the combination of those two will be the contact force on the rod at A, or ramp in this case. And then we've also going to have another contact force on at C. And because it's perfectly smooth, and this is why we're going to get the first answer doing this, let's call this one R just to distinguish it from N here. We've got that whenever two objects are in contact, these are the forces which are on the ramp, remember? And the reason why it's perpendicular to the ramp is because, and this is really, I could easily see myself getting this wrong in the test, like the reaction force or contact force is actually a combination of two forces, as it is down here, a normal reaction and a friction. Yeah, because it's perfectly smooth. If it wasn't perfectly smooth, you maybe have a slight friction like that, and overall your contact force wouldn't be perpendicular, it'd be off to the right. Yeah, so it's because there's no friction there that the contact force or reaction force, which is actually a combination of two forces, the normal reaction here and friction, both of those are contact forces, that's why this is perpendicular. If it was, because the drum which it's resting on, I believe it says is smooth, a smooth, solid, cylindrical drum. So our first answer for part A is simply because the drum is smooth. And I think they actually allowed for just saying that. Let me quickly check. I've got the answers up on another screen. Drum smooth or no friction, therefore reaction is perpendicular. Yeah, it's because the drum is smooth, so no friction, taking it slightly off the perpendicular. Taking reaction, because reaction is defined as both forces, a combination of both forces, slightly off the perpendicular. Yeah, it's important to notice that like both the normal reaction and friction are, they make up together, they constitute the contact force, because they're both contact forces, they're both reactions. You don't have any friction without a force acting in the same place, and you don't have any normal reaction without a force being applied directly to another object. So yeah, that's why it's slightly off the perpendicular. Okay, we've got to find the magnitude of the resultant force acting on the ramp at A. 9 marks. Well, we're going to have to do everything then for these 9 marks, aren't we? Because in these questions, and I've said it before and I'll say it again, you always have to take moments once, never more than once, and then you have to do uppies equal downies and lefties equal righties. That's how you do all of these questions, every single one. Okay, so let's have a go at it. Let's just check as well that I've read everything and I don't think I'm missing any forces. Well, should we start with the hard bit? Let's take moments. And I'm going to take moments at A because it knocks out 2 forces. It's almost always a good idea in these questions, take moments at A. Okay, remember that we're going to have to do distance, which is 4 for this one, because this is only 4 up to the middle, times by 20g cos theta, because I need the force, I need the perpendicular component of the force from where I'm taking moments from. So if I'm going directly to the point here, then I need the perpendicular, then I need, the component of the force which is perpendicular to the direction I've travelled from the moments up to that point, if you see what I mean. So I need 20g cos theta. And that should be equal to, because that one's taking it turning in that way, this force up here, which is just simply 5, that's the distance to it, and r, because it's already perpendicular. I don't have to resolve it into its perpendicular component of the force times distance. I always think in moments there's really two absolutely equivalent equations. It's force times perpendicular distance, or perpendicular component of force times distance. So there's two different ways of looking at it. Okay, we've taken moments. Also, what I haven't done at the start, which I really should have done, is quickly wrote down my sines and coses. Well, 7, 24, 25, I think is a Pythagorean triple. 24 squared, 576, plus 7 squared, 49, yes, 625, and so square root 25. And that's theta. Okay, so sine theta, that's going to be 7 over 25, cos theta, that's going to be 24 over 25. Get that done. It's probably wise to do that straight away as well. There's loads of sort of prep work in these questions. Do the prep work. Okay, I've taken moments at A as well, and that wasn't too bad for a moments one, was it? That wasn't too bad. The problem is the uppy downies and lefty righties are harder here, slightly. Yeah, if we do uppy downies, and I'm going to go straight up and straight down here, then I can say that, okay, the only awkward force here is the R, which is now off. Yeah, and I want to turn it into up, down, left, and right. So I'm going to draw my triangle like that. Yeah, because I want to equate with these uppy downies and this righty here. Well, that's going to be theta as well, isn't it? I hope you can work that out. There's lots of ways of thinking about it. How about we draw a right angled triangle down there? Then that's going to be 90 minus theta. And therefore, that is going to be 90 plus theta, because then it's going to add up to 180 degrees. Yeah, because this angle is clearly 90 minus theta, because that's theta and that's 90. There's lots of ways of working that out, though. Normally you can take a sensible guess that it's either theta or 90 minus theta, and in this case it is going to be theta, but there's loads of ways you can work that out. If I put a line up here, I could do like corresponding angles. That's theta, that's 90 minus theta, well, that must be theta. There's loads of ways. Okay, anyway, so let's do the uppy downies now. We've got n going up plus r cos theta. Well, that's going to be equal to 20g. I haven't actually read the question yet. It's occurred to me that I haven't even read the question. That's how confident I am that this way is going to work. I'll read the question in a minute. Lefty righties. Okay, F equals, there's only one thing sort of going a bit to the left here, and that's this R force, and so I need the R sine theta up there. Okay, I've got three equations, N, R, and F, three unknowns. I wonder what the question is. Find the magnitude of the resultant force acting on the ramp at A. Okay, well, the resultant force at A. That resultant force is going to be a combination of N and F, isn't it? It's the resulting force. And so we need N and F here, yeah? But to find N and F, we're probably going to need to find R as well. Because R we can find just plugging it in here, actually, because we know cos theta is 24 over 25, so let's find R. By the way, finding those three equations, let me have a quick look at the mark scheme, how many marks you get out the 9. 1, 2, 3, 4, 6. Yeah, 6. In other words, you've got 2/3 of the marks where we are now. Get that bit right. And what's more, we're going to get all 9 because we've got this nice and clear and easily set out. Okay, let's do it then. So R is simply going to be 1/5 of 80g times by 24 over 25, I think it was. And that equals, let's just work it out as a decimal. Well, actually, let's keep it nice, actually, at the moment. Let's have it as 1/5 of 8 is 16. 16 over 25, I think it's going to be 16 times 24. That's 384. I'm actually tapping this into a calculator. 384g over 25. Yeah, obviously you can do that on your calculator. Okay, we can now work out n from this, because we're just going to do 20g minus 384g over 25. 384g over g I've put. Silly me. Over 25. That's your R, and I need to multiply that by 24 over 25 again. Wow, that's interesting. Okay, let's work out n, because we can work it out as a decimal, because we just need the magnitude of the resultant force acting on the ramp at A. So I'm just going to work this out as a decimal. 20 times 9.8. I'm genuinely doing this on the calculator right now. Minus 384 times 9.8 times 24, if you like, over 25 squared. 625. Okay, I'm getting 51.5 for that n. Newtons. Okay, now I'm going to work out F. F is simply R, 384 G over 25, multiplied by sine theta, which is 7 over 25. I can work that out. That is 384 times 9.8 times 7 divided by 625. I'm getting 42.147 or 42.15. I'm going to round up to 15 just to make sure my final answer isn't thrown by a over rounding here. Hence, find the magnitude of resultant force. Well, like I say, the magnitude of resultant force is just basically Pythagoras' theorem on that, and that's because the resultant force is a result of N and F. If you like, F going a bit to the right and N going a bit up. We need to find the the magnitude of those combined forces, the result of those forces, and that means we just need Pythagoras. So magnitude equals 42.15 squared plus 51.5 squared, all square rooted, and that comes to, I'm just going to square that, plus 51.5 squared and square root, and I'll get, oh, didn't do that right, and square root the answer. Oh, not so good on my old calculator, and I'm getting 66.5 as the magnitude of my resultant force. Let me just check that answer. 66.5 or 67 is what they accept. Remember, they're super fussy about 2 or 3 sig fig in these papers. So, stick to 2 and 3 sig fig, or I think even the pure paper just says 3 sig fig. So maybe stick to 3 and err on the side of caution. Okay, so that's B. The ramp is still in equilibrium in the position shown, but the ramp is not now modelled as being uniform. Given that the centre of mass of the ramp is assumed to be closer to B than A, or sorry, closer to A than B, state how this would affect the magnitude of the normal reaction between the ramp and the drum at C. So it's got heavier towards A, yeah? It's got heavier towards A. And we've got to say how that's going to affect the magnitude of the normal reaction at C. Well, the closer, this is my thinking anyway, the closer the weight is to this, the more R is going to have to sort of retaliate, if you like. The more we lean towards C, the stronger R will need to become. And so the less we lean on C, the more we're just sitting down this end, the weaker R becomes. And so R will get weaker. R will get weaker as the centre of mass moves towards A. And that is the end of the question, towards A. Yeah. That's it, and that'll get you the marks, I hope. Okay, thanks for watching the video. Keep up the hard work. Bye-bye.